Here we go. Today you're doing section 6-4. And we've got to go back and relook at defining the trig ratios. And you're going to be able to define these trig ratios for angles that are past 90 degrees. So if you look at this picture right here that I have for you, we defined sine, cosine, and tangent for acute angles that were in quadrant 1. So for example, this is your x and y axis. You have a point, we call it xy, and I put in here 3, 5. I just made that up. Actually, let's make this, let's make it 3, 4. 3, 4. Because do you know what the radius is then? 5. The radius would be 5. Now, what is the definition? So this would be 3, this would be 4, and that would be 5. What's the definition of sine? Sine is the side opposite over the hypotenuse, right? Sine is opposite, side opposite over the hypotenuse. But the side opposite is the y value. So another way of saying sine, you could say the y value over, we're going to call this the r. That's your hypotenuse. So we're naming this leg x, this leg y, and this leg r. This is really not a leg, it's a hypotenuse. These are your legs. So adjacent is going to be your x value, your side opposite is your y value, and your hypotenuse is your r. So instead of saying sine is the side opposite over the hypotenuse, you can also call it the y value over the r value. So if I say what's the sine of the angle that's created passing through the ordered pair 3, 4, well you would have to use the Pythagorean theorem to figure out what the r value is, which I just gave you 3, 4, 5, that's a special triangle. So what would be the sine of this angle? It would be 4/5, opposite or y value over r, 4/5. If I said cosine, the cosine of this angle, we would use the word adjacent over hypotenuse, but instead of adjacent you can use x, the x value over the r. So the x value here is 3, so 3/5, and tangent is equal to the side opposite over the adjacent. Well, instead of saying opposite over adjacent, you could say y over x. And likewise, the cosecant would be r over y, secant would be r over x, and cotangent would be x over y. So that's what that whole first page talks about here. It talks about sine is opposite over hypotenuse or y over r. Cosine is adjacent over hypotenuse or x over r. And then tangent, instead of saying side opposite over adjacent, you can say y over x. Okay? So, and then here are your 3 reciprocal ones. So sine is y over r. Cosine is x over r, and tangent is y over x. And don't forget your 3 reciprocal ones. So cosecant would be r over y, secant would be r over x, and cotangent would be x over y. Now we're going to use this to do your first example, problem number 1. Everybody have problem number 1? Let's take a look at that. We have, it says find the sine, cosine, and tangent of the angle that passes through -3, -2. Well, where is -3, -2? It's right here. So think of this, you're going to always create a triangle, right triangle with the x-axis. So see, this is the triangle I'm talking about here. So what is, to get to this point, you starting here, this is your origin, you went over 3, this is -3, and you go down 2, this is -2. So you have this, I'm going to draw this triangle right here. -3, and this is -2. So that's your x value, and that's your y value. How do you find r? How are you going to find r? Anyone? Yep, -3 squared plus -2 squared equals r squared. So help me out. 9 and 4 is 13. And what's r? Square root of 13. So r is the square root of 13. So now when you do the sine, cosine, and tangent of the angle that's created by passing through -3, -2, what's the definition of sine? It's y over r. Well, the y value is -2, and the r value is root 13. Now, are you going to leave your answer like that? What are you going to do? Rationalize it. So your best answer is -2 root 13 over 13. Cosine is x over r. Well, the x value is -3, and the r value is root 13, and again, rationalize it. And then tangent is y over x. The y value is -2, the x value is -3, and simplify 2/3. Okay, and here's just another, here are the definitions. For any angle that goes past 90 degrees, sine is y over r, cosine is x over r, and tangent's y over x. So I want you to look at your homework. See this packet, 6-4? This is what we're doing. Questions 1, 3, and 5 are just like what we did. So, I want the sine, cosine, and tangent of the angle that passes through, that's created when you draw this picture. And you don't have to, but I'm going to for you. Where is 2, 7? 2, 7 is, let's say, here. So this is 2 and this is 7. What are you missing here? What's this? How do you find this? The Pythagorean theorem. You're going to do 2 squared plus 7 squared is your r squared. What is r squared? 53. What's r then? Root 53. So now we need the sine, cosine, and tangent of the angle that's created in standard position and passes through this point 2, 7. So how do you do sine? What is the definition of sine? It's y over r. So it's 7 over root 53, and yes, you're going to rationalize it. 7 root 53 over 53. What would cosine be? Two over root 53, or 2 root 53 over 53, and I did not give you a lot of room here. And what is the tangent? Tangent is y over x, so tangent would be what? 7 over 2. Okay, try number 3. Where is this point? If you were to sketch it, where is it? It's in this quadrant right here, quadrant 3. So the x value is -5 and the y value is -6. R, no matter where you're at, is always going to be positive. X and y can be negative, positive, but R is always positive. How do you find R? How do you find R, everyone? So you've got 25, you're gonna use the Pythagorean theorem. 61? Is that right? The equal sign after. R is equal to the square root of 61. So what is the sine, cosine, and tangent? Sine is, and if you want to write, this is how I remember it, I would keep rewriting these. So y is negative 6 over root 61, and then x over r is going to be negative 5 over root 61, and then tangent is x, y over x, so negative 6 over negative 5 is 6/5. And number 5. So you've got, you're gonna square these. Why are we doing that? Because we need the radius. So this is gonna be 100, and what's this gonna be? What's the square root of 3? What is 3? So this is 103. So what's r? Root 103. So what's the sine? It'd be negative 10 over root 103. I'm not rationalizing it, you can do that. Cosine would be root 3 over root 103. And tangent would be negative 10 over root 3. Now, what's different about 7, 8, and 9? These are actually easier because they are giving you a circle here. This is the x value and this is the y value. I'm going to do it for you, but it says it in the directions. The r value is given to you. Does anyone know what the r value is? 1. I'm going to prove it to you that it's 1. If you were to take these two values and square them, these are your legs, square them. And once we do the first one, we don't have to do the other ones. We don't have to find the r value, because I'm telling you it's 1. If you squared negative 2 over root 5, what do you get? What's negative 2 over root 5 times negative 2 over root 5? It's 4/5. And what's this squared? 1/5. And what's 4/5 and 1/5? 5/5. And what's another name for 5/5? 1. And what's the square root of 1? It is 1. So I just proved to you that the radius is 1. If you took these legs and squared them and added them together and took the square root, you get 1. So now, how do you do these three? Well, if r is 1, what's the definition of sine? It's y over r. Well, what's the y value? 1 over root 5 over 1 is 1 over root 5. And rationalize it. It's root 5 over 5. How about cosine? Cosine is x over r. So it'd be negative 2 over root 5 over 1, which is negative 2 over root 5, which is negative 2 root 5 over 5. Are you guys getting this? Mm-hmm. And then how about tangent? Tangent is 1 over root 5 over negative 2 over root 5. You know what happens to the root 5s? They cancel, and you end up with negative 1/2 as your answer. Yes?
Can I go too fast?
Sure. Okay, why don't you try number 8? Now, we don't have to prove that r is 1. It is. So, sine cosine, and tangent. Tell me how to do the sine. You guys don't all speak at once. It's negative, it's the y value over 1, which is that. Now rationalize it. Cosine. And tangent. Can you do that in your head? It's that over that. These are going to cancel. Your answer's going to be what? Anyone? Good job, -3. And number 9. What did we say r is? 1. So what's cosine? Why did I say cosine first? I wanted to say sine. Sine is y over r. It's just going to be -4/5. What's the cosine? -3/5. And what's the tangent? Anyone? Is it positive or negative? Why positive? The negatives will cancel. Okay. Okay, the next 4 problems. We did these yesterday, so this isn't too bad. I want you to identify an angle that's between 0 and pi. Where is 0 and pi? Here's 0 and here's pi. So an angle that starts here and ends here. Well, what these angles are huge angles. How do I know they're huge? Or they could be positively huge or negatively huge. How do I know that that's a big angle? How could I say this in another way? 13 pi over 6. Not change it to, you could change it to degrees, that's too much work. How about let's look at this as a mixed number. How do you make 13/6 a mixed number? How many times does 6 go into 13? With what left over? So you've got 2 and a 6th pi. Well, all the way around the circle is what? Is what? 2 pi, right? 2 pi. Think radians, guys. Think radians. So all the way around the circle is 2 pi. We want to be between 0 and pi. So we went around and then some. We want to take off 2 pi. We want to shave off 2 pi. So if we took off 2 pi, what would be left? Yeah, exactly. If you subtracted 2 pi from this, you would have pi over 6. That is the angle between 0 and pi. Now, what are you going to do with that pi over 6? In the directions, it says find the sine and cosine of that given angle. Well, what does pi over 6 mean to you? Does anyone remember what pi over 6 is? We did this yesterday. Here's your circle. Do you remember this yesterday? You'll remember it. This is 0. This is 90. This is 180. This is 270, right? What's this angle right here? 45. What's this angle right here? What's this right here? 60. Do you remember the equivalent in radians? What's this one? This is pi over 6. This is pi over 4. This is pi over 3. This is pi over 2. This is pi. This is 3 pi over 2. and this is 0 or 2 pi. So when I say, what's the sine of a 30-degree angle? Well, we learned 30 degrees. This is a 30-degree angle right here. This is 1, this is 2, this is square root of 3. So if I say what's the sine of 30, it's 1/2. If I say what's the sine of pi over 6, it means the same thing, 1/2. What if I say cosine of pi over 6? Cosine is a side adjacent over hypotenuse, so it'd be root 3 over 2. Now when you talk about a 45, draw a line right down here. 45, this would be 1 root 2. So if I say what's the sine of pi over 4, it's root 2 over 2. Do you get this? And if I asked you for this one, this is 60 degrees, right here is 60. This would be root 3, this side would be root 3, this would be 1, and that would be 2. So if I say what's the sine of pi over 3, it's root 3 over 2. So that's what they want you to do. You now have, you're going to use this angle, not this one, to figure out what the sine and cosine is. I didn't leave you guys a lot of room. Sorry about that. But I used like 8 sheets of paper to give you the notes and the homework. So if you write teeny tiny, you can squeeze it all in. So what you want to first do on this, you're going to first shave off 2 pi, which we ended up with our angle that was between 0 and pi is pi over 6. These are called, anyone know what these 2 angles are called? Starts with a C. These are coterminal. Now, that's a 30-degree angle. You've got to know these ratios. So pi over 6 is 30 degrees. They want to know what's the sine of pi over 6 and what's the cosine of pi over 6. Well, the sine of pi over 6 would be 1/2, and the cosine of pi over 6 is root 3 over 2. Now, before I move any further, we need to talk about the unit circle again. And there's 4 special locations. You've got to know this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. Does everybody agree? And this is also 2 pi. Everybody agree with that? Now, if we are on the unit circle, from here to here, you went over 1 unit, up 0. So this ordered pair is 1, 0. This ordered pair, if you go over 0 and up 1, this is 0, 1. This ordered pair at pi is -1, 0. And this is -0, -1. So if I ask you, what is the sine of pi over 2? Well, where is pi over 2? It's right here. And sine, by definition, is y over r. And by the way, r is always 1 here. R is 1. So all you have to do here to find the sine of pi over 2, what is the y value at this spot? 1. What's the r value? 1. So what's the sine of pi over 2? It's a 1. If I said, what's the cosine of 3 pi over 2? Well, where's 3 pi over 2? Right here. And cosine is defined as x over r. Well, what is the x value here? It's 0. And what's r? 1. 0 over 1 is 0. So you've got to know these ordered pairs. Always go to your x. When you do these ones, this is what I always do. I go like this. I draw my x and y axis. I go over 1 unit, up 0. I go over 0, up 1. I go over -1 up 0, and I go down 0, over 0, down 1. And then I say, okay, right here we're at 0 or 2 pi. Here we're at pi over 2. Here we're at pi, and here we're 3 pi over 2. And then you have to know, what is the definition of sine? Sine is y over r. Cosine is x over r, and tangent is y over x. So if I say, what's the sine of pi? I know where I'm at. I know the x and y value at that spot. So if I say, what's the sine of pi? You go here. Sine is y over r. The y value is 0. R is always 1. So the answer is 0. That's how you do those. Well, so go back to your homework. How do you do 9 pi over 2? Well, 9 pi over 2 is a very huge angle. How do I know it's huge? Turn it into a mixed number. How many times does 2 go into 9? How many times does 2 go into 9? 4 with how many left over? So it's 4.5. So what happened, this angle, this is what it did. It started here, and it went, there's 2 pi, there's 4 pi, it's right there. Where is it really? Where is this angle really? It's pi over 2. So what you have to do is you have to find a coterminal angle first and foremost that is between 0 and pi. So if this is really 4.5 pi, if we remove 4 pi, what's left? Pi over 2. That is going to be the angle that you're going to find the sine and cosine of. So find the sine of pi over 2 and the cosine of pi over 2. Well, where is pi over 2? Where is it? It's right here. And here's the ordered pair, 0 and 1. And what's the definition of sine? It's y over r, so it's 1 over 1. So this answer is 1. And cosine would be 0 over 1, which is 0. Next one, 16 pi. That's a crazy angle. How much are you going to take away? 2, 4, 6, 8, 10, 12, 14, 16. You're going to take 16 pi away. Where are you at? At 0. Where's that? Right there. So what's the sine at this spot right here? What's the definition of sine? Sine is y over r. The y value is 0 and the r value is 1. What's 0 over 1? And what about cosine? What's the cosine of 0? It'd be 1 over 1, which is 1. And the last one. -7/4. We've got to go the other way. We're going to add 2 pi to this, which is really 8 pi over 4. So if we added 2 pi to this, what do you get? You get pi over 4. And where is pi over 4, everyone? Where's pi over 4? It's a 45er, and you need to know the ratio, 1 root 2. So what's the cosine and sine of -7 pi over 4? It's the same as pi over 4 because they're coterminal. So sine would be opposite over hypotenuse, which would be root 2 over 2. And actually cosine is going to be the same. Are you guys getting this? Huh? Yeah?
Are we gonna get like a circle?
No, you have to memorize it. Yeah, sorry. Okay, these next problems. I need you to have a calculator. Can you quickly grab one?
Brett, you got one.
And the camera's running, so you know. So on these next 6 problems, these are called calculator problems. Why? Because these angles are not 90s, 180, 270. They're not 45ers, they're not 60s, they're not 30s. There's 7 pi over 2 is not an angle that we will commit to memory. Now, what I can tell you is if you look at all these problems, they're all in radians. How do I know these are all radian problems? If you see pi, or if you do not see what? That little bubble, the degree sign. These are all, like see this one right here? That is not 11 degrees, it's 11 radians. All of these are in radian mode. So what you need to do is check your calculator setting. Your calculator must be in radian mode. Make sure it's in radian mode. How do you do that? Well, you're going to turn your calculator on and go to the home menu and go to setting. Oops, I went too far. Go to setting and go to document setting. And you want to make sure that word says radian. If it says degree, your answers will all be wrong. So how do you change it to radian? Click on it and it's going to say, give you some options. Click on radian, hit enter, and then go right, make default, and hit OK. Is there anyone not able to do this? And I can help you. Questions? All right, now these are super easy. How fast can your finger type these? So go to calculate. So I want your answers, just give me 2 decimal places. So all you do is type in the word, get that trig, type trig right here, trig, and you're going to see sine, cosine, tangent. What do you want? Well, they want you to find the sine, the cosine, and the tangent of each number. So do sine. Now, I like that fraction button, which is right here. Click on that, get your fraction, and you're going to type in 7 pi. You guys know how to get pi? It's at the very bottom left under EE. Pi. And then over 5. And then arrow out and hit enter, and there's your answer. It's negative 0.95. Usually you go to 4 decimal places. I'll take 2 for now to make this go quicker. So there's the answer for sine. So the sine of 7 pi over 5 is negative 0.95.
Miss Audia, how do you get the pi?
It's right here at the bottom, right there. See that? You're going to click on it, and then do you see a window of different, and hit,
I got it.
okay. So now do cosine, we're going to do the same thing. 7 pi over 5. Hit enter. Tangent. and there's the first one. Those are your three answers. Now, all of these are in radian. So for number 16 and number 23, notice how you don't see the bubble? You're gonna make sure, when you do sine, cosine, and tangent for these, make sure you just hit sine, and then you're just gonna type in -17 and hit enter. Then do cosine, negative, as long as your calculator's in radian mode, you're good. These ones don't have pi in it, but they're still in radian mode. Okay, so what we're gonna do is we're gonna go up to 23 today, and we're gonna stop. So I want you to use the rest of the time, use these calculators, and give me the sine, cosine, and tangent of these. And you're done. That's it. Okay? Tomorrow we will continue on with the rest of this packet. Make sure you're here tomorrow because it gets a little harder.